Today I am in the classroom, so if my voice sounds a little bit different, it's because I'm not sitting at home in my living room. We are going to go on to applications of word problems, and although I mentioned in one of the earlier lessons that logarithms are used in hearing under decibels or magnitudes of earthquakes or it's another one that I can think of off the top of my head, pH, acids and bases in science. We're going to look at two different places because the typical place for advanced functions to go, and not the only place, but a typical place for advanced function students to go are either a business or money related field or science in general. I am going to cover the two topics of compound interest and also exponential growth and decay, which is my second lesson, and it's sitting here. So I'll do that after we're done this one, separate lesson. So you should have learned a little bit about compound interest in the grade 11 course. It's money math, and this is the formula. However, there's some pre-formulas, and although it's out of order, I like to call these pain questions, and I think it's pretty funny that pain, which I don't know if I pronounced that right, is bread in French, and bread is a slang for money, so I think that's pretty funny. So P is the starting amount of money, so it's how much you invest or how much you borrow. A is the ending amount of money, and that includes the interest that you're making. I is a little pre-formula where you take the percent that's given in the question and you divide it by 100, or you can mentally turn it into a decimal. You then also have to divide it by the special number, and I'll give you a special number list in this space in a minute. That means you'll have a calculation to plop into the I category, and then N is the number of years times that very same special number, so that's another pre-formula, and you dump that into the N category. So let's look at the special numbers, and they're pretty logical, I think. So I'm going to write this in tiny red. So the special numbers. So hopefully I can fit it in here because there's a bunch of them. So we've got the word annual, or let's try that again. Annual or annually. That means once a year, so your special number is number 1. The second word that you might see frequently, let's see if I can do it right this time, is semi-annual or semi-annually, and that means twice a year. Another word you might see repeatedly is the word quarterly, and quarterly means 4 times a year. Another popular one is monthly, and that's 12 times a year. And a final one that I can think of off the top of my head, but maybe not the actual final one, so I'll try to give myself some space, is weekly, and bankers use 52 weeks in a year. Something that might be worth Googling is how weekly, which is 52 weeks in a year, is related to a deck of cards, and a deck of cards has 4 suits, which represent 4 seasons. I think that's pretty cool and worth Googling if you are interested in the history of numbers. So if I need to add to this list, I'll come back and add to the list, but right now I'm going to move stuff around so I have some space to work. So the one thing I want to tell you is that sometimes you're going to get a money question where you're going to need to dig out the pain, and you'll do it and it won't be a logarithm question. And that's because what happens in this unit for a lot of people is they think, oh, this is the logarithms unit, so I must do logarithms every time. But that's actually not true. I am testing whether you know where to use logarithms and then how to use logarithms. So the first thing I look at here is I see the word compounded, which tells me I'm in compound interest, and it also tells me that I can dig out my list. So I will, for the next 2 lessons, dig out a list so I know where to put stuff before I start the main formula. So P is the amount of money. Better read the question. What amount of money would grow to $5,000 in 4 years if invested at 11.75% compounded semi-annually? So semi-annually is that 2. Because I've got these literally written right here, I might as well start with them. So I take the percent, 11.75%, which I'm going to turn into 11.75%. I divide it by 100, and I divide it by semi-annually, which is 2. Because what's happening is you're not going to get 11.75% twice a year, because that would be 23.5% over the course of the year. So they're going to split this up. So in total, over the whole year, you're going to get the 11.75%. So, calculator. Pause while I find mine. So I'm not going to show you all the button clicks this time. Do you hear that? It's my calculator. 11.75 divided by 100 divided by 2 gives me a fairly lengthy decimal. And the unfortunate business about this decimal is you got to keep all the decimal places for accuracy. You have to pretend that this is your money. And then n is the number of years times the exact same special number. So you're going to put this money in, however much it is, for 4 years, and you're getting money twice a year, so you're actually going to times that by the special number for a grand total of 8. Now, maybe the hardest part for you might be figuring out where the 5,000 goes, because the 5,000 is either the starting amount, and I put it in P, or it's the ending amount, so I put it in A. So let's reread. What amount of money would grow to, so this is the final amount. I'm growing my money to $5,000. And this is the question mark. So I'm going to dig out my main formula. And then I'm going to put the values in and see if it's a logarithm question or otherwise. So A is 5,000 equals P, 1 plus this decimal. I can do that in my head. To the n, which is 8. So this is not a logarithm question. And the reason it's not a logarithm question is because we can get P using pre-logarithmic math. So P times this bracket, all it is this bracket needs to be removed by its opposite operation. So I'm going to take it without actually calculating its worth yet, and I am going to divide it on both sides of the equal sign. And then I'm going to put that in my calculator just as it is and come out with a value for P. So 5,000 divided by bracket 1.05875, end the bracket, to the exponent 8 equals, now I get 3166, let me write down what I have, 3166.814448. You owe me a therefore statement. Normally I wouldn't write down all those digits because if I check my list, it says that P is the starting amount of money. And when we talk about an amount of money, we only need 2 decimal places to represent cents. So when I go to do my therefore statement, or you could have done it when you answered for P, we need to invest $ beginning or end, and to 2 decimal places, $3,166.81. So this question did not require logarithms. Next question. Maybe it will, maybe it won't. But because I see that this is a money question, and I'm talking about interest rates, I'm going to lay down my P, A, I, double equals, N, double equals. So again, maybe it's wise to do this stuff first. Or maybe read the question first. Usually I read the question about 3 times. Once to find out what it's talking about, a second time to find out where the values go, and a third time to see if I'm answering the question. So it says an 18-year-old investor has $2,000 to invest and wants it to grow to $150,000 by the time she reaches age 65. What is the annual rate of interest that she must get? So annual is different than semi-annual. Semi-annual, our number was 2. Oh, you're going to have to pause. There, that was my proof I was at school. So annual means 1. So it says, what is the annual interest rate? So I actually have no idea what the interest rate is. But I do know that in order to fill in the I blank, I have to take the percent, I have to divide it by 100, and then I have to divide it by the special number, which is 1. So we'll have to undo that when we figure out that blank. N is the amount of years times the special number. So we have to figure out what 65 minus 18 is, and then we have to times it by the special number, which I'm kind of wasting my hand strength, is 1. So 65 minus 18 is 47 times 1 is still 47. And now this stuff. It says an 18-year-old investor has $2,000 to invest, so that's how much she is going to invest at the start, and she's hoping to end up with $150,000 when she hits 65, so over the 47 years. So time to dig out the main formula. Which is that guy. And then putting in the values. So A is 150,000. Just go to my list. P is 2,000. I can't do that tricky business in the bracket this time because I don't know what I is, so I can't add it on, but I can put a 47 up here. So I have to go through the steps, mathematical steps, to get this I by itself. So because this 2,000 is not really 100% attached to the I can divide it on both sides and get 150,000 divided by 2,000 is 75 equals this bracket. Now, here's the hard part that you might over or underthink. To get rid of a little 2 up here, an exponent 2, you would square root. So in order to get a 47, in order to get rid of a 47, you have to 47th square root. And that is going to give you likely a terrible decimal. So before you write down that terrible decimal, I suggest that you take and write down the next step that's going to happen, which is that this 1, which is added, will need to be subtracted, and then we can come out with our I. So if I do that on my calculator, 47th root of 75 is equal to 1.09621293, and then I can subtract 1 in my head or on the calculator, and I end up with 0.09621293 if I want to write down all the decimals. There possibly is more. But I have to undo all of that stuff. So I have to take this number and I have to multiply it by 100 and I have to multiply it by the special number, which is 1 in this case, so it doesn't do a heck of a lot, before I answer the question. So therefore, the annual interest rate is, I'm going to say times by 100, we'll move my decimal here, times by 1 won't change anything. I'm going to say 9.6%, so you don't think, or my reader doesn't think that it's exactly 9 or exactly 10. So I've given a decimal point, which is usually how interest rates are given to you. So you had previous math to logarithms that let you pull off this question. So now we have, I think, 2 more questions. Before I forget, which of course I should have said off the top, you have all these on a worksheet or a sheet that you could print off from the Google site. I did put this on, as well as the exponential functions. Sorry, exponential growth and decay. I'm not sure I'm good in the morning as I am in the evening. All right, so I see the word compounded, and then I see the word quarterly. So I'm going to translate that quickly. There's my special number, and now I'm going to dig out my list so I can start the question. So I'm going to start with I again, because I can see that 9%. I'm not even reading the question. 9% divided by 100 divided by 4. So 9 divided by 100 divided by 4. All the decimal points written down, 0.0225. N. Oh, I better read the question. How long would it take for an investment of 200 to grow to 300 if invested at 9% compounded quarterly? So I don't know how long it is. So I'm going to put a y in here, and I'm going to times it by 4, because that's what I'm supposed to do. I'm supposed to take the number of years, whatever it happens to be, and times it by the special number, and then I'm going to pretty it up. So I'm going to make it look like that. So when I go to find the n, which is actually the answer for how long, I'm going to have to divide by 4, because here I'm timesing by 4. So now the money part. We're taking an investment of $200 and wanting it to turn into $300, and we want to know how long that's going to take. So formula time, main formula time. So A is 300, P is 200. I can do my snazzy adding in here, and 4y goes up top. So I'm looking for the y. I know I can at least divide both sides by 200. Sometimes this will be a nasty decimal, sometimes it'll be nice. Technically, you don't really need the brackets here anymore. I'm writing them down out of neatness. And there is absolutely no operation you know before logarithms that lets you get a letter down on the ground. So I'm going to do this in 2 steps. First step, log base 10, because we're super smart, both sides. Because what that lets you do is it lets you use the law of powers that says you can take this exponent and you can take it down in front. Again, no real need for this bracket other than this is a decimal, so it's kind of bulky and I want to draw attention to it. So now I have to get the y by itself. It's on the ground, as in it's on the main level, so that is a little less tricky than where it was. So I'm going to have to divide, because this is all multiplying, and I have to divide by log 0.0225 on both sides. But that's going to leave me 4y, and I don't want 4y. I actually want the y. I want the number of years. So I also have to divide by 4. So this is what I'm going to dump into my calculator, however you need to dump it into your calculator. And that's going to spit out the number of years, which is what I said y was. So I've got a display model calculator on my desk as opposed to the non-display model calculator that is part of the computer. So I'm hitting log 1.5. It doesn't open any brackets, so I don't need to close any brackets. Divided by log 1.0225. Divided by the 4 gives me an answer of 4.555663053. I'm not going to write all that down. I'm going to write it to one decimal place. So I'm saying 4.6. And then I can say it will take 4.6 years. And you could use the word approximately in there if you wanted to, because this isn't exactly 4.6 years. It's about 4.6 years. So this is going to be possibly one of the dumbest tricks I ever tell you about. And that is, number one, you know to use logarithms when the letter is an exponent, when the unknown is an exponent. That did not happen in this question. The unknown was the p-value, not an exponent. And in this question, it was the I-value, also not an exponent. So this question, the y was in the exponent. That's how you tell if you need logarithms. Another dumb way to know if you need logarithms is to pretend you have a stuffy nose. And if you say how long with a stuffy nose, it sounds like how log, which is kind of like how log, in which case it's telling you to take the logarithm. I made that up myself. The thing is, I can be super tricky and not always ask you how long. I can sometimes say, determine the amount of time, which means the same thing, so you would have to translate. All right, last question for today, or last question for compound interest before we go on to exponential in a totally different lesson, just to keep these a little bit shorter. Interest rate, I can pluck that out and not have to worry about it. So 8.75 divided by 100 divided by semi-annually, 2. I didn't have to read the question, I had to scan through it. 2, not 4. So 8.75 divided by 100 divided by 2 is, again, more decimal places that I really want to write down, but I need to keep this accurate. How long will it take $5,000 to triple? So I'm starting with $5,000, and I want $5,000 to triple. So I want to end up with $15,000. If the interest rate is 8.75% per year, so this little word right here, in case it has not happened previous to this, says per year, compounded semi-annually. So I have no idea how many years this is, but I know I have to times it by the special number, which is 2, so I have to deal with that. Main formula. And I hope that you can see that I didn't try to trick you. It says how long, which you could read how log, which means you're going to do logarithms. Other reason, real reason, when you put your values into the formula, you end up with an unknown as an exponent. Now you can't just go logging both sides whenever the heck you want to. The first thing you have to do is get rid of everything that doesn't have anything directly to do with the exponent. And again, sometimes this is a terrible decimal and sometimes it's pretty. And I'm going to take one less step this time than I did the last time, because my hand's cramping. And that is, I'm going to log both sides to get the exponent down on the ground, which is really bad math language. But I'm not going to do it in 2 steps. I'm going to take 1.04375, and not put the 2y here. I'm going to put it here. And then I'm going to say what I'm going to do to get the y by itself. So I have to divide both sides by log 1.04375. And I'm going to divide both sides by 2. And then let my calculator do the work. So log 3 divided by log 1.0375. Oh, water break. $1.04375 divided by 2 equals, and I get 12.82826204. So I'm going to write down 12.8. So therefore, it will take approximately 12.8 years. Now, if you're actually in this class and not just using this as a resource, I believe there is a compound interest sheet in your booklet, and these are the questions. So just beware that there are unlimited amounts of places that you can use logarithms in real life. Compound interest is one of the places. Because I'm a math teacher and I'm good with the math, I can answer money questions for people even though I don't fully understand banking and don't have a degree in finance. The next thing we do, maybe a little bit less familiar, is exponential growth and decay, but we'll get there with the next lesson. So, hey, not bad, under half an hour. Yay me.